For introduction, lighting is an essential service in all the industries. The power consumption by the industrial lighting varies between 2 to 10% of the total power depending on the type of industry. Innovation and continuous improvement in the field of lighting has given rise to tremendous energy saving opportunities in the area. Lighting is an area which provides a major scope to achieve energy efficiency at the design stage. By incorporations of modern energy efficient lamps, luminaires and gears apart from the good operational practices. Basic term in lighting system and features. Incandescent lamp. So incandescent lamp produce light by means of a filament heated to incandescence by the flow of electric current through it. The principal part of an incandescent lamp, also known as GLS, that is General Lighting Service lamp, include the filament, the bulb, the fill gas and the cap. Then reflector lamps. Reflector lamps are basically incandescent, provided with a high quality internal mirror which follows exactly the parabolic shape of the lamp. The reflector is resistant to corrosion, thus making the lamp maintenance free and output efficient. Lamps. Gas discharge lamps. The light from a gas discharge lamp is produced by the excitation of gas contained in either a tabular or a elliptical outer bulb. The most commonly used discharge lamps are the as follows: fluorescent tube lamp, FTL, compact fluorescent lamp, mercury vapor lamps, sodium vapor lamp, metal halide lamps. Lamp. Luminaire. Luminaire is a device that distributes, filters or transforms the light emitted from one or more lamps. The luminaire includes all the part of necessary for fixing or protecting the lamp except the lamp themselves in some cases. Luminaires also include the necessary circuit auxiliaries together with the means for connecting them to electric supply. The basic physical principle used in optical luminaires are reflections, absorptions, transmissions and refractions. Control gear. The gear used in the lighting equipment are as follows: ballast, the current limiting device to counter negative resistance. Characteristics of any discharge lamps. In case of fluorescent lamps, it aids the initial voltage built-up required for starting. Ignitors. These are used for starting high intensity metal halide and sodium vapor lamp. Luminant. It is required for the luminance size and incident on the element of the surface at a point of surface containing the points by the area of the element. The light level produced by the lighting installation is usually qualified by the luminance produced on the specified plane. In most cases, this plane is the major plane of task in the interior and in common called a working plane. The luminance produced by the installation affected both performance and the task and the appearance of the space. Lux. This is the luminance produced by the luminance flux of one luminant uniformly distributed over a surface area of 1 square meter. 1 lux is equal to the 1 luminant per square meter. Luminant efficiency. This is the ratio of luminous flux emitted by the lamp to a power consumed by the lamp. It is a reflection of efficiency of energy conversion from electricity to light form. Color rendering index. It is a measure of a degree to which the color of a surface luminant by a given light source conform to those of the same surfaces under the reference luminant. Suitable allowance having been made for state of chromatic adaptation. Lamp type and their features. So, type of the lamps, luminance, then color rendering is a typical application, typical life terms. So, here incandescent lamp have a range of 8 to 18 and then average of 14 watt. So, color rendering index is excellent and the typical application in the homes, restaurant, general lighting, emergency lighting, and here the typical life hour is 1000. Then fluorescent lamp have a range of 46 to 60 watt and the average of 50 watt. Good with respect to the coating, and then it will be used in the offices, shop, hospitals and homes. It and the lifetime is 5000 hours. Then the compact fluorescent lamp have an luminance that is a range of 40 to 70 watts and then average and 60 watts. Its color rendering is very good and it will be used in hotels, shops, homes, offices. Its lifetime is 8000 to 10,000 hours. Then high pressure mercury, that is HP ME. Here the range will be 44 to 57 watts. It's an average of 50 watts. It will be color rendering index is fair and it will be applied in the general lighting in factories, garages, car parking, food lighting. Then its lifetime is 5000 hours. Then halogen lamps, that is a range will be 18 to 24 watts. It's an average of 20. Color rendering index is excellent and hence the typical application of will be in the display, food lighting, flood lighting, stadium, exhibition, then grounds, construction areas. Its lifetime is 2000 to 4000 hours. Then high pressure sodium, that is HPSV, have a range will be in 67 to 121 watts. It's a range. Average is 90 watts. It will be color rendering effect is fair and it will be applied in general lighting in factories, warehouses, street lighting. Has a lifetime of 6000 to 12,000 hours. Low pressure sodium, LPSV, have a range will be 101 to 175 watts and average of 150. Its color rendering is poor. It will be applied in the roadways, tunnels, canals, street light. Have a typical lifetime will be 6000 to 12,000 hours. Recommended illumination level for the various tasks and activities and locations. So, recommendation of luminous scale of illuminance. The minimum illuminance for all non-working interior has been mentioned as 20 lux. So, a factory of an approximately 1.5 represents the smaller significant difference in the subjective effect of illuminance. Therefore, the following scale of illuminance is recommended. So, 20, 30, 50, 75, 100, 150, 200, 300, 500, 750, 1000, 1500, 2000. Less illuminance ranges because circumference may be significantly different for different interior used for the same application or for different conditions for the same kind of activity. A range of illuminance is recommended for each type of interior or activity independent of a single value of illuminance. Each range consists of 3 successive steps of the recommended scale of illuminance. For working interiors, the middle value of each range represents the recommended service illuminance that would be used unless one or more of the factors mentioned below and applied. The higher value of the range should be used at the exceptional cases where the row reflectance or contrasts are present in the task. Error or costly to rectify. Visual work is critical. Accuracy or higher productivity is of a great importance, and the visual capacity of the range may be used when the reflectance or a contrast are unusually high. Speed accuracy is not important and the task is executed only occasionally. Recommended illumination. The following table gives the recommended illuminance range for the different tasks and activities for chemical sector. The values are related to the visual requirement of the task, to user satisfaction, to practical experience, and to the need for the cost difference, the effective use of energy. So for recommended illuminance in other sectors, reader may refer illuminance engineering sector recommendation handbook. So chemical, petroleum, chemical and petrochemical work, interior walkways, platforms, stair and ladder, 30 to 50, 100, exterior pump and wall areas, 50 to 100 and 150, pump and compressed houses, 100, 150 to 200, process plant and remote control, 30, 50, 100, process plant requiring occasional manual intervention, 50, 100, 150, permanently occupied work section and process plant, 250, 200, 300, control room for process plant, 200, 300, 500. Recommended illumination for a paramedical manufacturer and the fine chemical manufacturer, paramedical manufacturer. So grinding, granulating, mixing, dyeing, tableting, 300 to 500 to 750. Fertilizing, washing, preparation of solution, filling, capping, warping, hardening, fine chemical manufacturers, exterior walkways, platforms, stair and ladders, 30 to 50, 100, process plant, 50 to 100, 150, for chemical finishing, 300 to 500 to 750, inspections, 300 to 500 to 750, soap manufacturing general areas, 200, 300, 500, automatic processing, 100, 200, 300, control panels, 200, 300, 500, machines, 200, 300, 500. Recommended illumination. Paint works general, 200, 300, 500, automatic processes, 150, 200, 300, control panels, 200, 300, 500, special waxing mixing, 500, 750, 1000, color matching, 750, 100, 1500. Methodology for lighting system. So energy efficiency study by step approach for assisting general efficiency of lighting system is given below. Intervised the lighting system element transformer in the facility as per the following typical format. In the case of distribution board being available, fuse rating may be inventorized along the above pattern in the place of transformer. Case 2. With the aid of lux meter, measured and document the lux level at a various plant locations at the working level as daytime lux and nighttime lux values alongside the number of lamps on during the measurement. Step 3. With the aid of portable load analyzer, measure and document the voltage, current, power factor and power consumption at various input points, namely the distribution board or lightning voltage transformer at the same as that of lightning level audit. Compare the measured lux values with the standard value as reference and identify the location as underlit and overlit areas. Step 5. Collect and analyze the failure rates of the lamps, ballast and actual life expectancy level from the past data. 6. Based on colorful assessment and evaluation, bringing out improvement options which should include maximize sunlight use through use of transparent roof sheet, north light roof, etc. Examine the scope for replacement of lamps by more energy efficient lamps with due consideration to luminance, color rendering index, lux level as well as expected life comparison. Replace conventional magnetic ballast by more energy efficient ballast with due consideration to life and power factor apart from watt loss. Select interior cover for light reflection. Then modified layout for optimum lighting. Providing individual group control of lighting for energy efficiency such as on-off type voltage regulation type. B வந்து group control switches, C வந்து occupancy sensor, D photo cell controls, E timer operated control, F pager operated control, G computerized lighting control program. Then install input voltage regulator controller for energy efficiency as well as larger life expectancy for lamps where higher voltages fluctuations are expected. Then replace energy efficient display like LEDs in the place of lamp type display in control panel, instrumentation area, etc. Energy efficient replacement option. The lamp efficiency is the ratio of light output in luminous to power input to lamp in watts. Over the year development in the lamp technology has led to improvement in the efficiency of lamps. However, the low efficiency lamps such as incandescent bulb still constitute a major share of the lighting load. High efficiency gas discharger lamps suitable for different type of applications offer appreciable scope for energy conservation. The typical energy efficient replacement options along with the percent energy saving. Saving by the use of high efficiency lamps. Domestic commercial existing lamp type la வந்து existing வந்து proposed existing வந்து GLS 100 watt proposed வந்து CFL 25 watt. For industry use, GLS 13 watt is that is existing. Proposed is CLF 9 watt. Then GLS 200 watt is existing. Blended 160 watt. Then TL 40 watt are existing. Proposed is TLD 36 watt. Then industrial and commercial use, HPME 250 watt is existing. HPME 400 watt is also existing. HPSV 150 watt and 250 watt is proposed. Then power saving, domestic and commercial for existing law, that is 75, also 75%. Then as compared to existing and proposed, power saving is 31%. Then for GLS 40 and 20%, TL 10%. Then industrial and commercial HPME 100 37%, 150 then 35%. For saving potential by use of the high efficient lamp for street light. Existing lamp GLS, replaced unit is ML, that is 200 watt, lifetime is 1000 hours. Replaced on the ML 160, lifetime is 5000 hours. Saving on the, that is 40 watt saving 7%. Then GLS 300 watt, lifetime is 1000 hours, type replaced by ML 250 watt and the lifetime is 5000 hours, saving is 50 watt, then 17%. TL 2x40, then 2 into 40, then lifetime is 5000. TL 2 into 36, lifetime is 5000 and the saving is 6%. HPME existing is 125, lifetime is 5000 hours. HPSV is replaced 70 watt, the lifetime is 12,000 hours. Saving is 44%. Then HPMB 250 watt, lifetime is 5000 hours. HPSV 150, 12,000, 100 watt, 40% saving. HPMB 400, lifetime is 5000. HPSV 250, 12,000, 150, 36. Some good practices in lighting. Installation of energy efficient fluorescent lamp in the place of conventional fluorescent lamp. Energy efficient lamps are based on the highly sophisticated tripurpose fluorescent powder technology. They offer excellent color rendering properties in addition to very high luminance efficiency. Installation of compact fluorescent lamp in the place of incandescent lamps. Compact fluorescent lamps are generally considered best for replacement of lower voltage incandescent lamps. These lamps have efficiency range from 55 to 65 watts. The average rated lamp life is 10,000 hours, which is 10 times larger than that of normal incandescent lamps. CFLs are the high suitable for places such as living rooms, hotel lounges, bars, restaurant, pathways, building entrance, corridor, etc. Some good practices in lighting. Installation of metal halide lamps in place of mercury. Sodium vapor lamps. Metal halide lamps provide high color rendering index when compared with the mercury and sodium vapor lamps. These lamps offer efficient white light. Hence, metal halide is the choice for color critical applications where higher the luminance levels are required. These lamps are highly suitable for applications such as assembly line, inspection area, painting shop, etc. It is recommended to install metal halide lamps where the color rendering is more critical. Installation of high pressure sodium vapor lamps for application where the color rendering is not critical. High pressure sodium vapor lamps offer more efficiency, but the color rendering property of HPSV is very low. Hence, it is recommended to install HPSV lamps for application such as street light, yard lighting, etc. Installation of high pressure sodium vapor lamp for application where color rendering is not critical. High pressure sodium vapor lamp offer more efficiency, but the color rendering properties of HPSV is very low. Hence, it is recommended to install HPSV lamps for application such street lighting, yard lighting, etc. Installation of LED panel indicator lamps in the place of fluorescent filament lamps. Panel indicator lamps are used widely in the industrial for monitoring fault indications, signaling, etc. Conventional filament lamps are used for the purpose which has got the following disadvantages. High energy consumption, failure of lamp is high, then very sensitive to the voltage fluctuation. Recently, the conventional filament lamps are being replaced with light emitting diodes. The LEDs have the following merit over the filament lamps. Lesser power consumption, withstand high voltage fluctuation in the power supply, longer operating life. It is recommended to install LEDs for panel indicator lamps at the design stage. Light distribution. Energy efficiency cannot be obtained by mere selections of more efficient lamps alone. Efficient luminous along with a lamp of high efficiency achieve the optimum efficiency. Mirror optic luminance with a high output ratio and bat wing light distribution can save energy. For achieving better efficiency, luminous that are having light distribution characteristics approximate for the task interior should be selected. The luminance fitted with a lamp should ensure that discomfort, glare and waning reflection are minimized. Installation of suitable luminous depending upon the height, low, then medium and high bay. Luminous for high intensity discharge lamp are classified as the follows. Low bay for height less than 5 meters. Medium bay for heights between 5 to 7 meters. High bay for heights greater than 7 meters. System layout and fixing of the luminous play a major role in achieving energy efficiency. This also varies from application to application. Hence, fixing the luminance at the optimal height and usage of mirror optic luminance lead to energy efficiency. Light control. The simplest and most widely used form of controlling a lighting installation is on-off switch. The initial investment for this setup is extremely low, but the resulting operational cost may be high. This does not provide the flexibility to control the lighting where it is not required. Hence, a flexible lighting system has to be provided which will offer switch off and reduction in the lighting level when not needed. This following lightning control system can be adopted at a design stage. Grouping of lightning system to provide greater flexibility in lightning control. Grouping of lightning system which can be controlled manually by the timer control.